So today we start trigonometry, and we're going to keep doing it for pretty much almost the rest of the course. So we're going to be looking at sine, cosine, tangent, and then we also have the reciprocal functions as well. It's important to note that these definitions only work when we're looking at right triangles, when we have a right angle there. We're only going to be looking at acute angles, angles less than 90 degrees. We can use these definitions. You're probably pretty familiar with these. Most of this section should be reviewed for you. A lot of people use the device SOHCAHTOA to help them remember these definitions there. You should also remember your special right triangle. Maybe the only little difference here is that we're going to be looking at these in radians as well. And so we've got, instead of just 30, 60, 90, we're going to be looking at pi over 6, pi over 3, and then pi over 2. One thing to keep straight is that pi over 6 is 30 degrees. 180 divided by 6 would be 30. And then pi over 3 is 60. 180 divided by 3 is 60. So over 6 goes with 30. The over 3 goes with 60. And then we've got pi over 4 instead of 45 degrees there. You can either remember these triangles as you first learned in geometry, or the unit circle version with the hypotenuse being 1 there. Either way. There's some Pythagorean triples as well that can save you some work doing the Pythagorean theorem. So one thing we'll ask you to do is find something like sine of pi over 6 without your calculator, just using these special right triangles. Again, instead of 30, 60, 90, look at them in the radian version. So if we're looking at pi over 6, the opposite side is 1, and the hypotenuse is 2. So sine would be 1/2. So when we ask you those questions, we just want you to know these special right triangles in radians. Then we'll have these questions where maybe we give you one of the trig functions and ask you for all the other ones. And so the first step would be to draw your triangle. Again, we have to have an acute angle in a right triangle to use these SOHCAHTOA definitions. So we'll put our angle here. We've got the adjacent side is 2, and the hypotenuse is 5. And so then there's just this other side that we don't know about. So we already know cosine is 2/5, and so cosine goes with secant. That's another thing to make sure you get straight there. That sine goes with cosecant, and cosine goes with secant, so the cos don't go together there. But then to find the other trig functions, we have to find this missing side, and this one's not a triple, so we do have to actually use the Pythagorean theorem. So we've got x squared plus 2 squared equals 5 squares. Just make sure when you set this up that you have the hypotenuse as the one that's by itself on the other side of the equation. That's the only thing that sometimes, if you're going a little too fast, sometimes people will mix up. And so then we get x equals root 21. Normally we would say plus or minus root 21, but right now we're just in geometry world where everything is positive. The side of a right triangle has to be positive. And so now that we know this other side is root 21, now we can find all these other trig functions there. So sine is opposite over hypotenuse, tangent is opposite over adjacent, and then we can do our reciprocal functions here. And now these answers are perfectly acceptable for me. There is the rationalizing the denominator that some people still do. When you look at answers in the back of the book, you may see those with the denominators being rationalized. We will not make you rationalize denominators, but you're certainly welcome to if you would like. So you could also give us this answer. And either one is perfectly fine. The only thing to watch out for is to make sure you know the difference between just rationalizing the denominator and simplifying. So just to give you a quick example here, if you have 2 over the square root of 2, that one actually would not receive full credit, because that's not just a matter of rationalizing the denominator. That one needs to be simplified. This one here, 2 is the square root of 2 times the square root of 2, and so that one simplifies to root 2. You could also rationalize the denominator 2 root 2 over 2 and then cancel the 2's. And so if you're not going to know the difference between simplifying and rationalizing the denominator, you might always want to rationalize the denominator just to be safe, but you don't have to unless it's a matter of actually simplifying. Now you can of course find a lot of these trig values in your calculator. You just always need to make sure you check your mode. So I sometimes recommend that for any of these three buttons, the sine, cosine, tangent, maybe just put a little piece of a sticky note on there just to remind yourself. When you're doing these here, you have to know if you hit your mode button, there's radians or degrees, and you have to be careful about which one you're in. So if I want sine of 25 degrees, it's not one of these special right triangle ones. We'll just use our calculator. So make sure we're in degrees, and then sine of 25, and we can find that answer. This one is about 0.423. Then this one, we got a couple things. So secant, there's no secant button. You have to just do the reciprocal of cosine. So you can do your alpha y equals to get a fraction. And you just do 1 over cosine. But the angle doesn't change. It's still the same angle. So you're still going to do 5 pi over 3. 1 over cosine for secant. And then be careful there. We just hit that cosine button. Anytime we hit one of those three buttons, we always got to remember, check your mode. So we're in radians now, so we have to switch from degrees to radians. So we can find that, and that one's just a nice simple answer of 2. Now you might remember using the unit circle to find those values. That'll be coming soon. Then we've got finding sides and angles in a triangle. And so for this one here, we do have a right triangle, so we can use SOHCAHTOA, we can use all those relationships. And so we've got the opposite and the hypotenuse. So sine, that'll be x over 15. And so here we want to cancel out divided by 15, so we will multiply it by 15 to both sides. And we'll just have 15 sine of 20 degrees is x. And so we can just type that in our calculator, 15. Oh, but hold on, I'm about to hit that button. Maybe put a little piece of sticky note right there. Be real careful. This is the worst way to lose points on the test. Before you hit those buttons, check your modes. I was in radians from the last problem. I've got to switch back to degrees. So 15 sine of 20. And this looks like about 5.13. And then on this one here, again, we do have a right triangle, so we can use SOHCAHTOA. It's like we have opposite and adjacent. So tangent of 55 degrees is 29 over x. Just be careful when the x is in the denominator. Make sure you're careful with that algebra there. Here we want to multiply the x over. We'll do times x to both sides. So we'll have x times tangent of 55 degrees is 29. And then it's the tangent of 55 that we want to divide by. Divide by tangent 55 degrees. And so x is 29 divided by tangent of 55 degrees. And unless somebody snuck up and changed my calculator mode, I should still be in degrees, so I should be fine. 29 divided by tangent of 55. It's like about 20.306. Now for finding angles, one option is the simplest thing right here. We're not even looking at sides. We just have two of the angles. We know the third. Hopefully you remember from geometry, the angles of a triangle add up to 180. Those are supplementary. But then if it's a right triangle, we already have one of the angles is 90 degrees. So the other two have to add up to 90 degrees. Those are called complementary. So 50 plus this angle has to equal 90. So x has to equal 40 degrees. On this one, we have to use something else to find that angle because we don't know this one. We've got some sides here. It is a right triangle, so we can set up a SOHCAHTOA relationship here. We've got opposite and adjacent, so it'll be tangent. It's going to be tangent of x equals 11 over 5. So we've got kind of a problem there that x is stuck inside the tangent function there. You can't divide by tangent. Tangent by itself is meaningless. It's a function. You have to have that input there. What we actually want to do is switch the input and the output. Here we're inputting an angle and outputting a ratio of sides. We want to switch those. We want to input the ratio and output the angle. You might remember from the last half of the class, there's a type of function that does switch the input and the output, which are called inverse functions. So we've got tangent inverse, and now we can input the 11/5, and it will output the angle x. All right, so I'm still in degree mode. I want to keep that in mind. Because now when I do this, you're doing second tangent to get that inverse. If you look above tangent, it has that tangent -1. Second tangent for inverse tangent of 11/5. So a little more than 65. And I said it was important that we knew we were in degree mode. That's just so that when we write this answer, we say that it actually is in degrees. You could also be in radian mode if you preferred. You could switch your mode to radians and then do the exact same thing, and we'll give you a different answer, and that one's in radians there. And so if you write your radian answer, all you do is you just don't write a degree symbol. If an angle does not have a degree symbol on it, it's automatically in radians.